I often find myself using this toy motor, due to it being very small and very good for its size. However, recently, I've needed a motor with more torque instead of speed, and since I have a 3D printer, I've decided to print my own gearbox instead of buying one. After all, how hard could it be? I decided to make a planetary gearbox, as it is very space efficient. After doing a few calculations, I landed on this. This will create a 6:1 gear ratio, which will cause the output shaft to spin at 1/6 the speed, but will also have 6 times as much torque. After printing it and testing it, it looks like it works quite well. So I decided to create a housing and an adapter to let a motor be the input. After designing and printing it, I started to test it again. And it didn't work. I think the reason the gears can't move this time is that before there wasn't a bracket holding the ring in place, so it could bend slightly, and without that extra movement, the gears are getting stuck. To combat this, I added more tolerance to the planetary gears by shrinking them down, the planetary gears being the 3 large gears in the middle of the gearbox. And after printing the gears again, they started to move. However, they didn't turn well. I think it's caused by the large amount of resistance caused by the uneven surface left by the supports. So I decided to print it again upside down at the cost of larger supports and longer print times. After reassembling it again, the gears started to turn much smoother, but after attaching the other panel, it became hard to move again. So I added a slight notch to each gear, reducing the friction even further. After all this, it was finally time to test it. And after attaching the motor to the gearbox, it looks like it's working quite well, but I'm not quite happy with it just yet. There is a lot of wobble in the output shaft, and the gearbox is making a lot of noise, so I redesigned the output shaft to make it more stable. I made it thicker and thickened the area of the panel that it goes through in order to create a more guided path for the output shaft. And it looks like it's working a lot better now. It goes without saying, but these are nowhere near all the problems I encountered. Fixing these problems and the countless others I encountered took the better part of 2 weeks, and I still need to figure out a way to make it quieter. While running it, I started to smell a slight smell of plastic, probably caused by small bits of the gears flying off. I realized that I never even checked how fast the motor was moving, so I decided to check. I attached a piece of tape to the end of the motor and turned the motor on. I then recorded the sound the motor generated while I rubbed my finger against the piece of tape, and opened the audio in Audacity. Here I zoomed in and saw the individual sounds generated each time my finger contacted the piece of tape. I then measured the time it took for the piece of tape to hit my finger, and found it to be 0.006 seconds. I then calculated the RPM by dividing 1 by 0.006 seconds to get the rotations per second, and then multiplied it by 60 to get the rotations per minute, which came out to be 10,000 RPM. It was now obvious to me that it might have been a better idea to apply a bit of lubrication, so I added some. After running the motor again, the gearbox produced a lot less noise and even rattled a bit less. I've added a link to the model in the description. If you have any suggestions or improvements, please leave them in the comment section down below. Thanks for watching, I hope you enjoyed the video and see you next time.